Quadratic functions. We've discussed functions in the past. If you recall, a function is an equation such that for each input there's exactly one output. The easiest way to determine if a equation is a function is by the graph. So since we're working with quadratics, we know it's going to be a parabola that either opens up or down. And the vertical line test tells us that if any vertical line crosses a graph at more than one point, it is not a function. So if we randomly sketch some vertical lines through these parabolas, we know that every vertical line will only touch the graph at one point. Therefore, all quadratic equations are functions. So we can certainly write them as functions, evaluate them as functions, and so forth. And they, of course, have a domain and range. Example 1, given the quadratic function f of x is equal to negative 4x squared plus 16x plus 13, we're asked to find f of negative 2. In other words, evaluate the function when x is equal to negative 2, so substitute the value x equals negative 2 into the function and simplify just using the order of operations. No parentheses to work, so exponents negative 2 squared gives us a positive 4. Multiplication, negative 4 times positive 4, negative 16. 16 times negative 2, negative 32, plus 13. Simplifies to negative 35. So when x is equal to negative 2, y is equal to negative 35. For that one input, we get one output. And it's still a solution to the equation, so it's still a point on its graph. The parabola would cross through the point, negative 2, negative 35. Example 2, given the function g of x is equal to 3x squared minus 7x minus 11. Evaluate the function when x is equal to 4. So same thing here, evaluate the function by substituting in x equals 4 and simplify. For one input, x equals 4, we get one output, y is equal to 9, which is one solution to that function, the 0.49. Example 3, given this quadratic function, f of x is equal to x squared minus 11x plus 30, we're asked to find the values for x when f of x is equal to 0. So just basically working backwards, keeping in mind that f of x is the same thing as y. So instead of substituting a value for x and solving for y, we're going to substitute in this value for y and solve for x, which basically boils down to solving this quadratic equation. It's already in standard form, so it factors into x minus 6, x minus 5, giving us two values for x. X is equal to 6 and x is equal to 5. And example 4, another application problem. Just understand the problem. We do not have to derive the function ourselves. In this case, we're given the function. We just have to make sure we clearly understand what it stands for. First of all, x represents the number of years since the year 1974. And g of x is the number of people that have earned a master's degree in mathematics or statistics since 1974. So what we're asked to do is find the number of people who have earned a master's degree in statistics or math since in the year 2014. So we're solving for g of x. In order to do that, we have to plug in a value for x. So to find x, subtract 2014 minus 1974, which of course is just 40. Substitute that into the function. 6 times 40 squared minus 224 times 40 plus 3941. Order of operations simplify. It works out to be 4581. So we know what the graph of a quadratic once again looks like. A parabola that either opens up or opens down. So one application problem with quadratic functions, and a pretty common one, is a velocity function. What's going on in one of these problems is something is going up into the air, and of course if something goes up, it's going to come back down. So if we sketch that out, we have of course the ground here. If you, for instance, throw a ball up in the air, it's going to go up and eventually come back down. If we sketch the path that ball follows, we see it looks like a parabola, or at least a piece of a parabola. We know that technically a parabola is going to go down to infinity in both directions. So we're just taking the piece above the ground, and the ground is represented by the x-axis. So it's going to be a parabola that opens down, and we're looking at the piece of the parabola that simply lies above the x-axis. So in example 5, a football is kicked up with an initial velocity of 64 feet per second. The football's height above the ground in feet after t seconds is given by the function h of t is equal to negative 16t squared plus 64t. So we don't have to derive the function, we just have to understand what it stands for. T, of course, is time measured in seconds, and it's the time after the football is kicked. H of t, then, is the height after t seconds. So A, use the function to determine how high the football will be above the ground after 1 second. So we're given a time, which that allows us to solve for h of t. In other words, just find the height after 1 second, find h of 1, so substitute t equals 1 into the function, and simplify. Works out to be 48, and since it's an application problem, include your units, 48 feet. So after 1 second, the football will be 48 feet above the ground. Part B, how long will it take for the football to come back and land on the ground? So here, working backwards, using the function backwards, instead of giving a time and asked to find the height, we know a height. Well, if it's on the ground, the height is 0. So substituting h of t is equal to 0, that allows us to solve for the time t. The quadratic function is already in standard form, equal to 0, so factor out negative 16t. We're left with t minus 4, and just by factoring out the greatest common factor, it's completely factored. Set each factor equal to 0 and solve. The first one, t is equal to 0, t is equal to positive 4. So what we just found here are the times that the football will be on the ground. Well, of course it's on the ground before it's even kicked. T equals 0 seconds, and it's on the ground after 4 seconds, after its kick goes up and then comes back down. So we have to make sure our answers seem reasonable, that we've answered the question. Well, the t equals 0 is not what the problem was asking us to find. We were asked to find how long will it take for it to come back and land on the ground, which is the t equals 4, more specifically t equals 4 seconds. Similar problem, example 6. We have this function here, where a softball is thrown upward from an initial height of 48 feet. So basically, if we sketch that out, we have the ground, we have a platform that's 48 feet high, a softball is thrown up, and it's going to eventually come back down and hit the ground. Once again, we're asked to see how long it takes for it to land on the ground. So if it's on the ground, the height is 0, so 0 is equal to negative 16t squared plus 32t plus 48. Solve this quadratic. Greatest common factor, negative 16. Factor it out, we're left with t squared minus 2t minus 3. Continue on factoring. Negative 16 times t minus 3 times t plus 1. So 3 factors, but only 2 of the factors have a variable, so we only set 2 of them equal to 0, so that gives us t is equal to 3 and t is equal to negative 1. The 2 times that the softball would be on the ground are technically when the parabola crosses the x-axis, the x-intercepts. Only one of them answers the question, though. That negative 1 doesn't make any sense. That would be before the softball is even thrown. It would go backwards to go into the ground, so of course time can't be negative. We would want the positive 3 after it's thrown up and comes back down and hits the ground. So t is equal to 3 seconds.